Hey everybody, welcome back. This is part 2 of our two-way Anova example with Dr. Amy Gates and our how-to video series. If you recall from part 1, we were looking at a two-way Anova. We had two independent variables of video access and gender, and we were looking at a dependent variable of total class points. We said this is our set of null hypotheses, and this was our corresponding set of research hypotheses, and we were about to run our test in SPSS and analyze the results. So let's do that now. Using our data set in SPSS, to run a two-way or factorial Anova, we click on Analyze, General Linear Model, and Univariate. A lot of students will contact me and say, but you have two independent variables, wouldn't you choose multivariate? And that's a very good question. The answer is no. The multivariate stands for the number of dependent variables that you have. In our case, we're only looking at one dependent variable, and that's total class points. So we're going to use a univariate Anova test. Once I click univariate, and let me go ahead and put these guys back. You can see I've run this a few times. I want to tell SPSS which one is my dependent variable, and I know that that's total class points. Then I want to tell SPSS which ones are my independent variables. Notice I can have as many independent variables, or fixed factors is sometimes what they're called. I can have as many as I want to. That's why sometimes this is called a factorial Anova, because you can have as many fixed factors or independent variables as you want when you look at your one dependent variable. Well, I have two fixed factors or two independent variables. I have gender and I have video access, which I've spelled incorrectly, just ignore that. Once I tell SPSS my independent variables and my dependent variable, my next step is to tell SPSS to build me a plot so I can see the interactions if there are any. I want to run a post hoc on any of my independent variables that have more than two groups, and I want to see some descriptive statistics. So let's click on plots first. In this case, and the rule of thumb is when making your plot, choose your independent variable that has the most number of groups. This one has 3 groups. Put it on your horizontal axis. I can put my other variable, gender, on a separate line on that same axis, and when I click Add, which I cannot forget to do, it's going to generate an interaction plot between video access and my gender, and that's exactly what I want to see. That little star stands for interaction. Whenever you see that, that's what it means. Now click Continue. Next I'm going to click on Post Hoc. I want to run a post hoc for my video access. My video access has more than 2 groups, and so I want a separate table that compares each one of those groups to each other. I'm going to use Chiffé to do this comparison. I don't have to run a post hoc on gender because gender only has 2 groups. So I don't need to make a multiple comparison between each group with every other group because there's only 2 groups. So I can just look at the means. But for video access, I have 3 groups, and I want to see whether each of those 3 is significantly different from the other. And that's what the post hoc is going to give me in a separate table. I'll click Continue, and then finally I'll choose Options. I want to see the descriptive statistics for everything. I want to see it for gender, I want to see it for video access, and I want to see it for the interaction between gender and video access. Clicking Continue, and then I'm going to run my test. Clicking OK. So let's see what kind of results we get here in SPSS. Let's move that over a little bit here. Make this a little bit bigger. And we can see that we get a lot of output from SPSS, and if we look at it closely, it all makes very good sense. In this first chart, we see that we have both of our genders, our male and our female, and we have all 3 of our video access groups. We have our every week access, which was a 1, our every other week access, which was a 2, and our no access, which was a 3. This N is the number of people in each group. We had 10 males and 10 females. And we have a nice even distribution of video access too, which came out well. All right, our next table is our descriptive statistics. This is done by male video access, female video access, and total students, male and female, video access. Let's look at some of these means. When our males watch the videos once a week, they have a mean of 708 for their total points. But when they watch it every other week, their mean's actually higher. That's interesting. Also, when they have no access, their mean is pretty low. Also interesting. For females, once a week gives them a pretty high mean. Every other week, their mean's actually lower. So this is interesting too. We're going to see an interaction here because males prefer every other week. Females actually preferred once a week for video access. So this difference may in fact prove to be significant. Again, no access to the video resulted in a low total class points. So we're probably going to see a significant result there as well. Looking at the total for male and female, we see that the no access to videos does look significantly lower than either once a week or every other week. So we're probably going to see some significant results in our Anova test. Here's the results for our Anova test itself, called Test of Between Subject Effects. Here are the three variables that we're looking at: our gender, our video access, and the interaction between gender and video access. Remember, we had 3 null hypotheses and 3 alternative hypotheses. They correspond to each 3 of these variable results. Let's look at the p-values here. Remember, in order to have a significant result, in order to be able to reject the null hypothesis, our p-value or our significance value has to be less than our alpha value. 0.097 is not less than 0.05. Our alpha here is 0.05. Even though this is a small value, it's not less than 0.05. So for our gender, this is not a significant result. We cannot reject our null. And so for that first null hypothesis that says, is there a significant difference between the mean points and our gender, the answer is we cannot reject the null here. There's no significant difference for our total points between our genders. So this null is not going to be rejected given what we see here in our results. However, video access does have a significant result. 0.001 is less than 0.05. So we can reject the null here, and we can conclude that there is a significant difference in our video access. So for that particular null hypothesis, we're going to reject this null, and we're going to go with our research hypothesis that there is a significant difference in mean total points between our 3 video access groups. We're allowed to reject the null because our p-value of our Anova test was less than our alpha value. It's less than 0.05. Finally, our interaction between gender and video access also has a significant result. It is also less than 0.05. So again, we're going to be able to reject this null. We're going to reject this, and we're going to conclude that there is an interaction, a significant interaction. There is a significant interaction between video access and gender. And that's what our results are telling us. So, in conclusion, and we'll look a little bit more at the results, we actually rejected our first null because there was a significant difference between video access. We did not reject our second null because there was not a significant difference between our genders, but we did reject our third null. There was a significant interaction. So, in result, we actually did the following. We are rejecting this one, we are rejecting this one, and we are rejecting that one. So this is actually kind of a short way of looking at what happened in our test. Our null hypothesis for gender was not rejected, but we were able to go with both of our research hypotheses for video access and for the interaction between video access and gender. Let's look into that a little bit more. Knowing that both of these results are significant, we can come down here and we can look at our Scheffé results. We have some significant results here, and we also have some that are not significant. Again, when our results are less than our alpha value or less than 0.05, we have significant results. This tells us that watching the video once per week versus once every other week for all of our students combined is not significantly different. But watching once a week versus not watching at all is very significantly different. Similarly, again, having no access to the videos versus watching them every week, very significantly different. No access versus every other week, significantly different. So all of these zeros are significant, but these two values of 0.256 are not significant. So this Scheffé test is showing us that while there is a significant difference among video access, there is not a significant difference between every other week and every week for all of our students combined. Finally, we want to look at the interaction between the males and the females versus video access. We'll actually notice that watching once per week worked a lot better for our female students, which are in green. But watching every other week worked a lot better for our male students, which is in blue. Neither of our genders liked having no access. But here's our significant interaction. It's illustrated very profoundly. Definitely the females preferred every week watching the videos. Definitely the males preferred every other week. That's a significant difference. And that's why we actually saw in our results a significant difference between the interaction. So those are our final results. And thank you for joining me for an example of our two-way ANOVA testing in SPSS.